and I'm delighted to introduce both of the speakers. First of all, I'd like to introduce Dr. Jennifer Schopf, who currently leads the Indiana University's advanced high-performance networking efforts worldwide. This includes operating and managing two very large networking projects, TransPac 3 and America Connects, two European initiatives. Dr. Schopf has also served as a program officer at the National Science Foundation in the Division of Cyber Infrastructure, where she really changed the thinking across many of the different divisions of the National Science Foundation. She also jointly led the EarthCube program that I know many of you have been tracking and following and participating in. She's also been a scientist in the Mathematics and Computer Science Division at the Argonne National Laboratory, and she is a graduate of the University of California, San Diego, where she studied computer science and engineering. So Dr. Schopf, thank you for coming. We know just how busy you are. And thanks for giving the opening keynote.
Thank you, Peter. I appreciate the grateful introduction, and I appreciate the opportunity to talk to everyone from the Delta Science program. This is a really fascinating project that Peter and I started talking about, I guess, about 2 years ago. We met when I was working at NSF, and he was overseeing the EPSCoR program for Idaho, and a lot of really fascinating data issues. Oh, crumbs. Well, this is going to be interesting if the rest of the slides look like this. I think we've got a Mac PC issue going on here. Right, so I'm going to talk about 3 different pieces, and by all means interrupt me and ask some questions if you've got them as we go along. I'm going to talk a little bit about NSF data management because I think that's one of the cornerstones of how we're looking at science these days and how that's changed how scientists, government-funded scientists, view their own data. I'm going to talk a little bit about how we work with data. This came out of conversations. When I was at NSF, I was actually a scientist at the Woods Oceanographic, working with oceanographic folks. Through happenstance, as Peter mentioned, I'm a computer scientist by training, but a lot of really fascinating work is going on in geosciences and climate scientists because you can't do your science without sharing data in those spaces. And then, as Peter mentioned, I'm currently running an international networking program, so I'll talk a little bit about how we're viewing geoscience data in that space. I wasn't going to have introductory slides, but then Laura Rotman from ESNet gave a fascinating presentation at Torino just a couple weeks ago talking about how the DOE Office of Science is looking at big data problems now. For a long time, DOE Office of Science are working with high-energy physicists. They're in this box here on the left. I'm sorry, on the right. But more and more, we're seeing greater use of data in this kind of medium-scale collaboration and these smaller ones as well, where people are sharing data, not because you want to, but because you have to do your science. And these are the communities that are rapidly growing and facing a lot of questions about how do we actually do this? In the DOE Office of Science space, the Earth Systems Grid Federation is one of the big projects they're working with. This used to be the Earth Science Grid, Earth Systems Grid. Back when I was at Argonne, we've been working with them for a long time. NCAR has been working with the Office of Science and others, sharing this climate data. This is a graph of how their data has grown, in part through the use of ICPP. And this is only growing over time. When I started at Indiana, I stipulated that geoscience, climate science use of networks was going to grow. And I had no data to back this up. And my boss kind of looked at me and was like, no, we talk about high-energy physics, we talk about astronomy, bioinformatics, and all the sequencers, those are out there. You know, that's where you should be looking. And I said, no, geoscience and climate science. And I was proven right just recently. This is some information I've just gotten on one of my links. I currently oversee a whole bunch of links to Europe and a whole bunch of links to Asia. This is what we call a top 10 talkers list. So it's anonymized data of people using the network. It's anonymized to the level of the university. Check this out. 6 of my top 10 talkers are sharing geoscience and climate-related data. I don't know exactly what data. I don't know who they're sharing it with. But this goes on a bridge to a huge set of peering networks in Asia. A lot of the problems that you've seen here with the Delta Science Project here, we're seeing in the Lower Mekong region as well, for example. The same delta problems there, the same changes of salinity, the same encroaching of the different climates, the urbanization problems. we're seeing this more and more, and this is only going to grow. So I think part of this sharing of science and part of this sharing of data is why NSF took this data management plan approach when they did. When I started at NSF, this would have been 2008, 2009-ish, right around the time of the stimulus, which was a fascinating time to be at NSF. It's actually, we had more money than we knew what to do with for the first time, I think, ever. That lasted about 3 months. NSF has always had a data sharing policy. This goes back over a decade where the policy was, if you create data using NSF funds, using federal funds, you must share this broadly. However, it really wasn't enforced in almost any program, geoscience being the exception. The Ocean Directorate required all of their data sharing much sooner than almost any other part of NSF. So a number of us were familiar with this but hadn't seen it enforced. NSF came across and said, okay, well, we're not going to change our policy. We are going to require a plan. We're actually going to enforce the policy that we've got on the books. So, and this was a huge to-do at the time. What do you mean I have to share my data? And they came up, I was part of a large group. We argued over this for literally years before it went public. It is still being argued. It is still growing and changing. And it was meant as a first approach to a more comprehensive approach to data across NSF and across federal-funded science in general. So after January of 11, any proposal that came in had to have something called a data management plan. What's in a data management plan? It wasn't specified on purpose. NSF left this open and was to be driven by community standards because what I need as, say, a computational scientist is going to be different than what a high-energy physicist needs, is going to be different than what a climate scientist needs. So they left the plan ambiguous and open to interpretation. It was going to be part of the merit review process. If you've been on a panel in the last year, most of them now ask the reviewers, what do you think about the data management plan? One of the programs I'm applying to and have friends who are reviewing for, just recently I had somebody on a panel get in touch with me and say, hey, so this really is required, right? Because I think these guys should have had a plan, and they say they're not really sharing data, and I don't think that's right. And I said, well, you're the reviewer. You can put in it, you can say, this shouldn't get funded. I'm going to downgrade my ranking because you're not talking about how you're sharing data. You can say, I don't need to share my data. I can't share my data. It's unanonymized patient data, so I can't share it. And that's fine if it reviews that way. I think you should be careful if you do that and back it up pretty well because I've seen that backfire. So NSF tried to avoid a one-size-fits-all approach. It was subject to peer review. You can request additional funding. NSF did not define what data was. And this was, again, on purpose. Because any of you who have, this is how many angels can dance on the head of a pin? Is it observation data? Is it modeling data? Is it software? Is it metadata? And what's the difference between metadata and data? Because I've been in a lot of conversations where my metadata is your data. And, look at the phone records that the NSA have been collecting, right? That's just metadata, right? You shouldn't be worried about that at all. No, not at all. It's just metadata. Well, hey, that's pretty good data to me. NSF didn't define data. I had my own working definition of data when I was going around and talking about this. And because I'm looking at why am I sharing data? I'm sharing data to reproduce results. So in my personal definition, data is anything you need to reproduce your science. So that might be the raw data. It might be information about the tools I've used to change the raw data into something that makes sense. It might be the software. It could be the schema I'm using. I need to give you everything you need to reproduce the results. In my personal definition, that's what data is. Data management plan can include all sorts of stuff. We actually have tools now that help us create these. They were meant to change over time. There is a really great data management plan tool that the University of California and University of Virginia have supported. It's actually used a lot by people now in their proposals. It's actually a good tool to just walk through and think about, how am I working with data, and what are my sources, and what are the things I need to think about here? And this data management plan requirement was a first step in changing how NSF viewed data in general. There was a recent change in this year's grant proposal guidelines that said when you include your biosketch, your little mini NSF CV, you don't have to include 10 publications anymore. You include 10 research products. And one of those research products can be your data sets. It can be your software. It can be your patent. So looking at data as a more holistic result, the outcome of a funded project isn't just a publication anymore. It's the data and everything that went into it. And I think in the Delta Science program, you're seeing that a lot. You're seeing that it's more than just the publications that come out of this. We need to understand the collaborations and the coordinations and the sharing and the policy. So the NSF data management plan requirement, I strongly felt, was a really great first step. It was a really great first step in getting scientists to think and write down pragmatically, what are you going to do with your data once you've collected it? How are you going to share it in a reasonable amount of time? How are you going to make sure other people can have access to this, which is federally funded, so they should? However, sharing your data, putting it in an archive somewhere is really just the first step. And some would argue it's the easy step. And I know we're going to have a couple conversations this afternoon. A couple other speakers are going to go into this in way more detail than I'll be able to. Because it's one thing to archive your data. It's another thing to find it. It's something else entirely to be able to reuse somebody else's data. Because Bob Grossman from University of Chicago has a saying that every piece of data you want is out there. It's just all in the wrong format. Anyone who's ever taken somebody else's data and trying to use it for their own stuff, something that they're assuming, I'm assuming that the elevation is a known quantity, so I don't need to include it in this table. Well, shoot, that's the one piece of data that I actually needed to add in there. And I can get that from over here and add it to this data set. And gosh, this is just a complicated mess, isn't it? Making sense of somebody else's data, all of these things are really, I think, the hard problems of data. So when I started going around and talking to folks about the NSF data management plan and talking to people about how are we actually thinking about data, and when I was at the Woods Oceanographic, I actually was hired in part to help them figure out what they were going to do with their massive amounts of data. They were on the path to become the world resource for oceanographic and climate data, and they still are. We started talking about, well, what do we want to do with data to begin with, and how should we be talking about data? Everybody's talking about publishing data, and the model that everybody had in their head was like a book. I collect my data, have my sensors out there, and I collect my data together, and then I fasten it up into a nice bound thing, and I give it to you, and here's my data. Except that's really not how people were using their data. People were doing all sorts of weird, random stuff with their data. We were trying to collect it in different ways. We were trying to tag it in different ways. We were trying to really look at how to do this and trying to figure out, well, what other things do we do like this? And I'm a computational scientist by training. So I said, well, we do a lot of stuff with software. Maybe instead of publishing our data, we should be thinking about releasing our data. Maybe we could look at some of the things we do with software, which we've been doing software. That was the third leg, not the fourth, as Peter pointed out, and figure out, can we do this with data? Because we know something about building software. There was a really great issue of Nature a couple years ago which had all of these beautiful statistics about how much more everyone is using software in their science and how much more people have to think about actually having software that gets used by other people in their science. Could we take some models from that and try to figure out could we use our data that way? So a bunch of us sat around, and the next 6 or 10 slides are the results of a lot of random conversations and probably a fair amount of beer at times. We talked about, well, what do we do with our software, right? Our software goes through a lifestyle. It starts off where, and most of us who have written any kind of software had this happen. I was actually part of the Globus project, so I saw this in the wide scale. You write something small that you use for yourself, and you're the only person using it, and what's testing? Testing is, it looks like it runs okay today. And you just kind of compile it and use it. And then at some point, somebody realizes that you've written something that's useful to them. And maybe my group will pick this up and we'll start playing with it. And, the end users are just the people in my group, and we're all kind of mucking around with it. And the testing is still kind of use, and the documentation is, maybe someone will get around to writing a README because they get tired of answering questions at 3 o'clock in the morning of, hey, what was the input to this function, and how did I get that file in here? And, and then someday you wake up and you get an email from someone you've never heard of saying, hey, I'm really enjoying the use of this tool, but I had a question about it. And you're like, how did you even get my tool? How did you ever figure this out? And so you realize, okay, well, we actually kind of have to think about what we're doing here because this has now gone live, whether we thought it was or not. So this is the same as a data set, right? I had a piece of data and we were using it and sharing it, and all of a sudden it's out there. Everything on the web is out there, right? Anyone who's ever, I had somebody find a random video of me from 2002 the other day, which was terrifying. No idea how this was out there. It was a DOE interview about why I liked working for Argonne. I had very short hair. So you start to formalize and think about taking this piece of software and turning it into production. And you might have some test cases because there are a number of errors that come up, and you might have some better documentation. And at some point, as an academic, you might actually have this as academic production, I think of it. It's not real production, but it's stable for other people to use. It could be used by a lot of people you don't know. You could actually give a talk about it, and people download it when you go to a meeting. The coding's generally done by a larger group, and by this point, you've had to formalize how the coding is done. You've had to talk about how you want to structure it, and you talk about how people can add pieces to it. You talk about what testing means, and what documentation means, and how do you actually release the software. It's not just there for anybody to take anymore. You actually have a plan and say, okay, well, here are the features we'd like to add, and in 2 months, we're going to have about like this out there, and this will be used, right? So this is a process I've gone through with almost every group I've worked with scientifically for the last 20 years. We've had pieces of software that kind of go through this process. So the question was, okay, so if we have these various features when we talk about building academic production software, could we relate them to data? Could we treat our data that we're collecting now, that we're sharing now in ways that we didn't used to share our data this way? Think about it. 10 years ago, I collected my data, nobody ever wanted it. My thesis data, nobody ever wanted that. Now it's expected. Now it's needed. Now it's required for my funding. If you're in NIH, it's been required a lot more. I've actually heard about NIH turning down people to get new grants because they haven't been able to share their data from the last grant. Not just the reporting, but... Yeah, so the comment was, it's not that nobody wanted my data, it's that nobody knew it existed. And I think that this is also a change in mindset. One of the fascinating things that's happening at NSF, and I think Peter hit on this a little bit, where he talked about, I wrote down my notes here somewhere, science and scholarship are now team sports. I love that image. If you look at the number of single PI grants from NSF, this is going down. If you look at the number of collaborative grants, this is going through the roof. I'm part of the generation where we've always done collaborative science. I remember I met my PhD advisor, it was late 80s, early 90s, and she said, here are the end users we're going to work with. And I was like, we're going to do what? End users. I'm a computer scientist. I'm going to talk to chemists? Really? Okay, this is now standard. I would not do science where it wasn't going to be used by somebody where it wasn't interacting with end users. That's not fun for me. So now that we're sharing data in a space that we didn't used to, how do we think about it? And I've got 3 or 4 slides. We'll just run through these quick. This is about sharing, right? If we're not sharing, you don't need to do any of this. If you have data sets that you don't want to share with people, ignore the next bit. When I show the pretty picture of a map on the wall, you can tune in again. But if you want to share your data, if you want to look at reproducible science, these are some things to think about. In the software world, you have a local archive where you take things and you munch them around, and then you put them out into a public archive. And you actually have a process for how you do this. And you have checks when you go into your local archive for code. For data, you might think about doing this too. One of the really valuable things we put in place for some of the WHOI data sets we're collecting are just really high level. Are the columns in the right order? Are the numbers kind of in the bounds that we thought they would be in? This isn't even doing any kind of error correction, just hey, did the temperature thing come in and say it was 150 in the Atlantic today? Because that's probably wrong, regardless of which scale we're using. Have we met boundary conditions? So there's some kind of sanity check. And in software land, this is kind of the sanity check before you check in any code, even locally. This is what you would check on, right? When we move to a more formalism process for data, we've got to start thinking about metadata standards. This is how you make your data understandable. So, the correlation in programming, I think, is when you start adding comments. When you start adding metadata so that someone else can understand what, EXP means, or LA, or, any of the wonderful abbreviations that we've all seen, and then, even you don't remember what they were 2 weeks ago. I don't know how many of you have had the wonderful opportunity to go back and find some data sets that you've collected, say, even 5 years ago, but more like 15 or 20. There are mysteries. If you can't figure them out and you collected them, that's a bad sign. So trying to do some of these things early. And metadata is hard. And I have been in rooms where people have argued about metadata standards way more than you want to. Craig Stewart's a good friend of mine. He's at IU, it happens, and he says, biologists would rather use somebody else's toothbrush than somebody else's metadata standard. And that's probably true. But there are hundreds of ontologies. I have been places where, none of these ontologies work, and there's actually a wonderful XKCD cartoon about building new standards and how, we want to build one standard to bring them all together, and then the next thing, hey, look, we've got yet another standard. It's hard, it's horrible, but it's a necessary starting point, and come up with the least common denominator if you can, and work from there. Testing, quality assurance, quality control, bug fixes. We need to make our data useful, and bug fixes is a great way to do that. This is one of the reasons I don't like the data publish model, is because data publishing, I publish a book, and I don't make corrections to that book. I don't make corrections to that paper unless it's really something horrendous. But with your data, you're often going to make little tweaks and updates to it. Somebody will say, hey, could you add in this column as well? Or, you've got this labeled this way. Could you add on, where you got this from or what these units are? Hey, I noticed this value, which is obviously wrong. Could you just tag it obviously wrong so that someone else doesn't run across that? So some people want your data before you've done those checks too. So in high energy physics, for example, the analogy of the biologist not wanting to, we use somebody else's toothbrush instead of metadata is a lot of the high energy physicists would rather use somebody else's toothbrush than trust their, precursor analysis. They insist on doing it themselves. But, a lot of people are really quite happy to have that first cut done. We talked about bug fixes. This is really a smart thing to do. And the other thing that you do in software, every time you write a bug, you should write a test so that you don't make that bug again. You can do this with your data, too. A lot of us have long-term running sensors. And there are certain things that happen to them over time that happen over and over. Throw in a test to make sure that you're not catching that data set in a weird way. Documentation is yet again how you make your data useful. Simply publishing a data set, a file, an Excel spreadsheet, a set of values, however you do it, is not sufficient. Again, this is you can find the data, but you can't do anything to it. We're looking at how to make this useful. And actually, if you put documentation on your data sets, this is a great way for someone to find out more about your science and your other data sets and what you're doing and how you're creating knowledge. This is a great place for you to put a plug-in for, hey, if you like this data set, we've also been doing work in these areas, and you can work with us on that. Discovery is a huge problem. Remember life before Google? Finding anything is hard, as mentioned. Figuring out the right way to put your data in a place where it can be discovered. There are hundreds of archives out there. They don't cross-reference each other. These are huge problems that different groups are working with. EarthCube is addressing that, as Peter mentioned. The Earth Systems Informatics Group is also looking at a lot of these issues. And I think for data, it makes sense to have a formal release process, the same way we do for software. So not a publication, And Peter Fox and Mark Parsons have published a couple papers looking at this and talking about metaphors. And again, the same way as having the right tools change how you approach your science, having the right metaphors in your head change how you talk about your results and change how you talk about what you're working with, and having the right mappings of this. So we're big proponents. So data isn't software. I actually saw somebody who posted a rebuttal to my treat data like software talk and said, but data isn't software. No, I never said it was. I said we should treat it like software. We should think about it as a changeable, growing, living thing. We should treat it like we're doing releases over time. We should treat it like something that when somebody comes back to us with a question or a good idea, we add that in the same way we'd add a feature into a piece of software. Licensing. Part of how Peter and I first started having conversations back when he was still in Idaho was about how do you license and cite software? This is hard. I think we're going to get some conversations about that in the next talk, in the following talks. Creative Commons licenses are used a lot now. 5 years ago they weren't. Every data set should come with some kind of citation information. It's some way that someone else can find it if it's used. So we've got all these different bits and pieces I've walked through, and it's basically about making your data something more than just something you can find. You can do these correlations. This is great. I've got little papers written on this. There's actually a video out there on this guy as well if you really want to. It's got pictures of my dog in it for reasons that have nothing to do with the actual talk, but highly recommend it if this is of more interest. But even if you have data that's great and it's discoverable and people can use it, part of what I'm dealing with in my current job. So a year ago, I moved to Bloomington, Indiana, to run an international networking program. I'm not a networking guy. I'm a data guy. I'm a high-performance computing guy. I was a Globus guy for years. I was an NSF guy. I liked living in big cities. And now I live in Bloomington, Indiana, which is small. But the best networking university in the country, arguably. We run the Internet 2 network, we run NOAA's research networks, we run a bunch of NIH's networks, we run a bunch of NCAR networks. If you want to do anything cool with real pragmatic networks, Bloomington's your place. We actually have openings too. But what we're doing a lot more of now is thinking about, well, how do people actually use networks? So I inherited a $2-3 million a year program with networks to Asia and networks to Europe of varying capacities. We got about 100 gigs of traffic plus going to Europe and about 30-40 gigs going to Asia, which is pretty cool. And the way that networking worked traditionally, so what I inherited was a program where people thought about networks as we need to have a big network, we need to have a big circuit, we need to have a big backbone. Let's make sure that they run. Let's make sure the other network engineers know just how big my network is. And then let's get a bigger network, because we need more. This is my style. The way I'm looking at this is, okay, well, I have a big network. It's a fabulous network, and the guy before me has spent 20 years putting it together, and it is great. And we have partnerships all over the world. Who's using my network? So that gets us back to the graph that I showed at the very beginning with my top 10 talkers list, which took me only 8 months to get a graph of who's using one of my network links. And it was fascinating because who we thought were using the networks weren't the people using the networks. And with even that high-level data, and it's anonymized because of data privacy concerns, again, you've got to consider that when you share your data, we can start thinking about, well, are they happy using this network? Are they getting the kind of performance that they expect? Well, they probably have no idea. Think about it. When you're at home and you're downloading a video or something, okay, so if it takes 5 minutes, that's probably okay. If it's still going after 20, something's messed up, and I should probably call Comcast, right? Same with your science data. I have a data set, and if it takes too long, I'm going to say, hey, something's not right here, but I don't really have any idea how long this should take. So what we're trying to do now is work more closely with people who are sharing the data and using the networks. And so part of what I've been trying to promote over the last year, and I'm going to continue, is how do we go from this space where this is an actual science group that my ESNet buddies have been working with, where they shipped disks back and forth, which certainly is data sharing. I actually ran into a group at IU who ships pallets of disks to Kansas every 2 weeks. It's just easier for them. This is their culture. We've always shipped disks. Can we work with you to get your data faster? Can we work with you on how you access your data? Because with these tools, as Peter mentioned, you will change the science questions you're asking. Think about, any of the online interactions we have. You're in a new city, you want to find a restaurant. What did we used to do? You'd ask at the hotel maybe, or maybe you'd ask a friend ahead of time if you thought about it. How many people do that now? You got your phone, you got Yelp, you got all sorts of things that will help you find places to go, maps to get you there, and other, we interact with things differently because we have tools that give us data and knowledge in a different way. What if we could do that with our science data? So, my predecessor, knowing that this was something I felt passionately about, worked with NSF and got us a supplement to one of our grants where we are specifically working with end users to use some of these large backbone links. Specifically, this is a 100G transatlantic link. So we're sharing data between the U.S. and Europe. There's a lot of data that gets shared between the U.S. and Europe. They're putting in place an experimental link to do that. And we got money not to buy the new big fancy circuit and to show all our networking engineers, but hey, my network is bigger than your network. This is, how can I get people to use this network? We've got people who are using this at a low level. How can we get them to use it at a higher level? How can we push these large flows in ways that we couldn't do a year ago or 2 years ago, that we didn't even think about doing a couple years ago because we didn't have backbones this size? So, all of a sudden, this is, you've got a freeway opened up. How do you find the other bottlenecks? Go into that freeway so that you can actually use it. I flew in via Houston yesterday and came in over Houston, and I don't know anything about Houston, but the traffic there at about 5:30 is dreadful. Except it's not. So when you fly in, you go over, and there's this huge freeway that was practically empty because the feeders to it were completely blocked. And there was like 2 lanes going to an empty 6-lane freeway, and if you could get all the way over and get onto that, you were great. We have the same thing happening in our research and education networks today. So when we talk about data sharing, one of the things I want to push is, as an application guy, I know you don't want to talk to the network engineers, I know you don't want to think about these problems, but take some time and try it. Because we're trying to talk to you guys now. We're trying to talk to the application guys, and we're finding out things like the language issues are horrendous. The words that network engineers use and the words that application scientists use, same words, really different meanings. And this is hard. And but you see this even anytime 2 groups get together, you see this. I'm sure as you've been talking about climate science issues, when you get people, the oceanographers versus the atmospheric guys, you've seen this too. This is one of the things that I look for when I work with any new group now is, how are we using the same words and meaning really different things, and can we catch it soon enough before it's a big deal? We've got really hard problems getting to these backbones. If we could get to the backbones, we'd be fine. But somewhere on a campus, there's some little tiny router, or there's an archive that hasn't had the interfaces upgraded. There's a lot of these issues. We need to share more information about this. Again, if you're interested in these issues, I'm spend hours of my life talking about these, mostly to network engineering folks, and telling network engineers, yeah, you really have to talk to the people using your networks now. Because, this is another way that science is changing. It's not just about using the hardware. It's about making science out of it. We're promoting science. One of the ways we're doing this, and I wanted to let folks here know, is Internet2 and ESNet, which are the 2 big U.S. networking groups, are running a focused technical workshop looking at issues of climate science and data sharing. IU is one of the groups behind the organization of this with NCAR and NOAA. It's actually going to be at NOAA in July. Registration is open now. It's limited to about 80 people because of room size. The agenda just got posted this week. This is a fabulous opportunity if you are looking at data issues and climate science issues and data sharing, to talk to network engineers and to talk to different groups in the US and internationally for how can you share data better, pragmatic sharing of this information. And we're going to be doing more of these. This is the only way I can come up with to actually get these groups to get together and talk about real things. And then after this, we have our 101 one-on-ones and figuring out, okay, really what's going on here. But I wanted to tell people about this meeting because I think it's really relevant to a lot of the issues you're looking at. So really quick, a takeaway from this, because I know we're running a little bit past schedule. Data archiving is a first step, not a last step. I think NSF did a really great job in requiring people to do that first step. Let's see how we can grow that. As you grow beyond just data archiving, really think about how other people are going to use your data. Think about the models you want for that. And when we talk about sharing data, let's talk about how you can change how you do science by sharing data. If you had access to other people's data sets as they were published, how would that change what you did? If you could pull these things up dynamically and on the fly, wouldn't that change the kind of questions you'd ask? Wouldn't this change how you approach some of these things? If I could pull up models that compared the California Delta to the Lower Mekong Region Delta and see, okay, well, they made this change, this happened there. They put in these dams there, and this is the effect. How would something like that affect us here? Wouldn't that be fascinating? And I should mention, I'm bringing up the Lower Mekong a couple times because we actually have funding. We're running a workshop there in August as well. If you're interested in that, please come chat with me. That's a larger scale project with the State Department. This is me. This is my group. We're hiring, as I mentioned. We're all required to put we're hiring on every slide because we're hiring and have been. And I'll be around all day today and tomorrow for questions if people have them. Thank you.